Hello, Barney. Welcome.
Hi.
It's nice to meet you.
Yeah, you too.
Is your last name pronounced Sowood?
Sowood, yeah.
Okay, great. Looks like we've got some people joining. Where are you all joining SaltConf from today? Got Utah, Iowa, Pennsylvania. Wow, Norway. Got some variety in here. I'm near Salt Lake City, Utah. Where are you at, Barney?
I'm in Scotland, in Edinburgh.
That's great. So is it evening there for you then?
Yeah, it's pretty dark already, unfortunately. So.
Barney, are you normally on a boat?
Yeah, I live on a boat normally,
really?
but I decided from a connectivity talk point of view, it's probably sensible to come somewhere else. Plus, I'm cat sitting for a friend, so at some point we may get interrupted by an excitable kitten, but hopefully not.
Okay, well, let's go ahead and get started now that we've got some people joining. I think we're up to almost 70 people now. So welcome. I hope you've all had a good SaltConf so far. My name is Serena Jolly. I'm a user experience designer at SaltStack, and I'll be moderating today. And this session is for Barney Sowood. He'll be talking about strategies for testing salt states, and he is an infrastructure automation consultant at Corsac Limited. What we'll do today is after this presentation, we'll take about 10 to 15 minutes to answer questions. So you're welcome to ask questions throughout the presentation. You'll see there's a Q&A panel. And if you go to that tab, it'll be on the right by chat, polls, and people. You can click the button at the bottom that says ask a question. And the neat thing about it is that you can upvote each other's questions, and we'll get to that towards the end and leave the last 10 minutes or so to filter out to the next meeting. But that said, I'll give the time over to you, Barney, if you want to introduce yourself a little better or get started on the presentation.
That's great. Thanks very much, Serena. Okay, so start with a little bit about me. As we just discussed, I live in Scotland, in Edinburgh, or just near Edinburgh normally. I work remotely as a consultant on various automation type projects, helping customers with config management, CI/CD, and automations tooling in general. My contact details on here if you want to get hold of me. I'm also usually on the SaltStack community Slack, just as Barney, so always good to grab me there as well. Just before I start, I also wanted to thank some people. Some of the work that led to this talk was done under contract with Untitled Chapter, who were kind enough to let me talk about those parts. So thanks to them for that, and also for generally finding the interesting salt projects to work on a fairly regular basis. The part of the work for Untitled Chapter was also at a company called Folksam in Sweden. So thanks also to them. And I should specifically mention my colleagues Daniel, Tommy and Frederick there, who have been involved in the work around salt testing. Frederick Lingman in particular has done a lot of work on the tooling around salt and CI/CD. And finally, I also just wanted to mention a talk that was at SaltConf 18 by Ethan Moore, because that was the thing that first got me thinking about using pytest to test salt states. So worth going to watch that if you haven't seen it previously. So strategies for testing salt states. How do you ensure that your salt states work? When you're first developing them, ensuring that they work probably means writing part of a state, pushing it to salt master somehow, trying to apply it, maybe with test equals true, then fixing any issues, pushing it out again, trying to apply it again. Maybe you have some dev environments to do this in. Maybe you have a setup to spin up a VM or a set of VMs on your local machine to test. But once you've been around that loop, possibly many times, you have a working state. Then perhaps you can push it to a Git repo and start using it on production machines. As time goes on, changes to states are made, team members come and go, changes happen to the systems being managed, new versions of Salt released. After all that, how do you know that states you wrote will still work in the way you intended them to do? So this is a talk about a set of strategies to test salt states as you're developing them. It's also about how to make sure that those states continue to work in the future, even as your infrastructure changes. It's about how to make it easy for people you're working with to test their states, or make changes to the states you've written, or states that were written some time ago but are still needed for some half-forgotten but critical systems. It's a series of strategies that start off with some tools to speed up initial development and testing, and then build on each other to eventually provide automated testing with CI. It's not necessary to adopt all these strategies I'll talk about, but hopefully adding any of them will help improve your states. What we'll cover: setting up a local environment, linting, building a test suite with pytest and Testinfra, using containers and CI to run tests, and testing against multiple OS and Salt versions. We'll cover each of these in turn. I'll show you how you can set them up and how they work for the testing of your salt states. I'll also show some demos for each part and show how each set of strategies builds on the previous ones. And I'll also talk about the types of issues each of the strategies can help with. So, local testing. When you're working on developing new states, it's important that you have a fast way to test those. Ideally, that should happen entirely on your local machine and not require any other infrastructure or even a salt master. It's important that you get a really quick feedback loop when working on states. If you're having to push states to a remote master or minion, or perhaps even having to push to a Git repo every time you make a change, this can quickly become extremely frustrating. It's particularly frustrating if the issues you're finding are errors in states due to bad formatting, syntax errors, or perhaps Ginger issues. If you continually have to go around a loop of trying to fix an error, testing in a way that'll take several minutes just to find another syntax error, it really slows you down. It also means that you're not doing what you should be, which is focusing on solving the actual problems that you're writing states to deal with. Making a local salt environment easy for everyone to set up means that you all get the same experience. People new to your team or writing salt states can get going quickly. They don't have to invent their own ways of setting up an environment or testing the states. Having a setup script and some simple documentation in the same repository as your states or formulas means that people have everything they need to get started in one place. Using Python virtualenv allows a really sort of lightweight setup. The advantage of this is that this will work on various people's development systems, so Linux desktops, Macs, under WSL on Windows, and also potentially natively under Windows if that's what you use. So the setup I'm going to show you is based on a single shared repository for salt states in the tooling. This would also work fine where you have formulas in a monorepo, or perhaps, if you have formulas in individual repositories, you could still make this work, although it would obviously take some additional work to adapt it. So this is the directory structure we've got. So essentially, I've checked out a local copy of the repository, and this is what the directory structure looks like at the moment. So as you can see, we have a few things in there. We've got some config files in etc. We've got a state tree under files, which will be familiar. You've got a directory for pillar data, although in this sort of simplified example we're giving, there's not actually anything in the pillar data. And then there's a README and a setup script. So as I talked about, making the tools for getting going with testing and development easy for everyone is a really important thing. So having a simple README and a simple way of getting set up, so that everyone has the same tooling and environment is really important. So just briefly to show you, we've got a script here called setup that anyone checking this repo out can use, and what that will do is check for any sort of requirements, prerequisites, set up a Python virtual env, and then using the requirements file and pip install salt and any other sort of requirements for running salt locally. Okay, so we're going to use the salt call command for testing locally. You've probably used salt call before for testing or running states from a minion. Essentially, salt call spins up a one-off minion. It can run anything a minion normally can, so execution modules, which we'll use to help test our states, or it can use state apply to apply states. What we have is we have some config in the repository to set up the salt CLI tools to work with the states in place in the working directory. So rather than needing to sort of copy states elsewhere to test out with your sort of working directory, we set the repository up so the tooling just works in place with the sort of state files that you're working on at the time. You can also use this set up for other CLI tools. So, if you want to do it with salt SSH, for example, it will also work. The way in which this is done is using the salt file. I don't think I don't know how much people sort of know about or use the salt file for setting up local config. It doesn't seem to be particularly widely used, and I do frequently see people using command line options to set config and end up running very sort of long command lines to try and use salt tools locally, and the salt file actually just really helps with that and helps simplify that. So let's just have a quick look at that. So just to briefly talk through that, if you've not used salt file before, essentially any of the salt CLI tools, if you when you run them, they will look in the current directory, and if there is a file called salt file and there is a config entry for the particular CLI tool, so in this case salt call, it will then read the config for that tool from the salt file. And what we're doing here is we're just using that to tell salt call to look for its config in the local etc. salt directory, rather than trying to look in the sort of system wide etc. salt. So so we have a local etc. salt, and then we have a really simple config file. It's actually, we use this both the same for master and minion. And what that does is sets the root directory to the current directory, does file client local. So that essentially says tells the salt minion, or within salt call, that rather than try and use a salt master for rather than trying to talk to a salt master for getting files and so on, to just do everything locally. And then we set these file roots and pillar roots again to be the local directories. Okay, so then we've got some really simple test states that we're going to use as we go through this, just to demo some of the things I'm talking about. So if we have a look at one of those, simple state to set up NTP, so install a package, run a config file, install a config file, and then restart the service and enable it if necessary. So we can just run salt call show SLS against that state, and we'll see the output from show SLS, and I'll come to that in a sec. Okay, so we can use the state module to test states using various functions within the state module. So we can test and validate our local states before we actually sort of try and apply them with state.apply on a real system. You probably used state.showSLS and state.apply with test equals true. I generally find that less people have used state.apply with mock equals true. We'll go through each of those and explain where we found each one useful, and give some examples of issues they can catch. Okay, so state.showSLS. You can call this on a single state file, and it will show the states that will be run. It will throw an error on basic formatting issues in the SLS file, such as sort of such as indenting issues or incorrect YAML syntax. It will also fail on missing Ginger variables or some Ginger logic errors. And it's also useful to check that the states you're expecting to see are there, especially when you've got sort of Ginger conditionals in. So you can actually just sort of eyeball that and see the states if you've got Ginger conditionals around sets of states, that they're actually appearing. What it doesn't do, it doesn't validate module or function names or arguments, but it is extremely quick to run. Okay, so we've edited this state file to add a formatting error. So if we run SLS, we'll see that that picks up that that there's a rendering error in that state file. So go and correct that. It again, and that's now working. Okay. Okay. So again, another error in that state file where we weren't forming the forming the arguments as a list, which it picked up again. Let's go and edit that. Fix it. Okay, so testing with state apply mock equals true. So again, you can just call it on a single state. And what actually this will do is it'll run through the sort of normal state apply process up until the point of actually calling the state function. So, for example, if you one of your states uses package.installed, it will go through everything up until the point of actually calling package.installed, and instead what it will do is it will return mocked return data. The useful thing from a testing point of view about this is that it will validate that this state module and function actually exist. So if you have typoed the name of a state module or function, it will pick up on that. It will also check the argspec for a function and throw an error if any of the required arguments are missing. That's useful, but not necessarily all the arguments to functions to work are required arguments. So it only picks up required arguments. Quite a lot of state functions take a sort of variable set of arguments and rely on KWRs quite a lot, and also rely on validating the parameters you pass into them at runtime, so it won't pick up on those. It is also useful for checking requisites. So if you are refactoring a set of states and perhaps renaming some of them, it's a really useful one to run to check that you've not broken any requisites. Still really quick because it doesn't actually call the functions. The other good thing about it is that it doesn't require your local system to have a similar setup or even to be the sort of same OS as what you're targeting with the state, because it's not actually going to call any of the state functions. Let's just go. Okay, so that's it running normally. And then if we've just introduced an error in the state, okay, so in that state, we'd change the package.installed to package.install. And as you can see, just by running state apply mock equals true, it's going to pick up on that and say it's not available. Fix that. Again, that's fixed. And this is just showing requisites. So we introduced an error into the watch any pointing at a non-existent state, and they're running this with mock equals true, picks up that. Okay. And then just briefly to cover state apply test equals true, which I think a lot of people use, especially on the actual systems you're going to be running your states on. But in terms of running this locally on your sort of local development system, it works in a similar way to mock equals true in that it goes through all the sort of normal state apply process. But unlike mock equals true, it does actually call the state functions, but calls state functions in test mode. So in some ways, that's an improvement from the testing point of view, because it means that any validation of arguments that the state function does will happen because the arguments in your state file are going to be passed to it, and it will also show you what changes will be made. But that's going to be on the local system, and it may well be that your local system is not the same as the systems you're targeting with your states. It could be a different OS, could be configured quite differently, and also this may not work for certainly for some state functions if you're working not as a root user on your local system, which sort of hopefully you probably aren't. Okay, so really simple state we're going to test with. I'm sorry, I think that was still one from mock equals true. I wanted to share. Okay, so that's test equals true running normally, and showing what changes it would make on the local system. If we introduce an error. Okay, so this one's quite interesting actually in terms of looking at validation of arguments by the actual module. If you see right at the top here, we've got a warning of use argument owner found, owner is invalid, please use user. So the file.managed state function specifically deals with the case of being passed owner rather than user for the owner/user of the file, just because I think that's really quite common in other coupled management systems. Yeah, let's fix that. Okay. Okay, we'll very quickly cover linting. So linting tools are usually specific to particular programming or markup language. They will validate files using a set of rules and enforce standards based on the rules and some config. You can usually use those to enforce local conventions. For example, if you have a particular naming scheme for salt variables or salt state names or so. We'll have a quick look at YAML lint and salt lint to help keep state and YAML data clean and readable. I'm not going to cover this here, but we have in the past added this to pre-commit, which is a tool for easily adding hooks to Git, so you can actually sort of catch simple things like linting issues before people push their states. So as state files are YAML, it's sort of quite tempting to try and use YAML lint on them. I have done that, and it will work on simple state files. But as soon as you've got any ginger in the state files, that doesn't work. And also, I mean, there's sort of syntax errors in the state file. YAML should get caught by the state module. I think it's probably less important to have, perfectly formed YAML. Still useful to include YAML lint in any automation you have within your repo, just to check your YAML files you might have. So for other things like GitLab CI or GitHub Actions. So just running it against a simple, running against a simple state file does work, although it complains about not having a document start. You can work around that by passing options to YAML lint, but frankly, that's going to be a losing battle, I think. If you try it then on a more complex state, with some ginger in it, you'll find that that doesn't work. So that you can use SaltLint, which will specifically check salt states. It checks against a series of rules. It understands Ginger with Ginger templating and actually has some rules for issues with Ginger. The default rule set for SaltLint is quite small. It is useful, but it's not massively comprehensive. It is possible to extend the rule set if you want to. So as you see, SaltLint just works on that. If we introduce an error with some Ginger formatting, you'll see that SaltLint picks that up. Fix those. Sorry. Okay, and then we can just wrap those in a script so it's nice and easy to run those. Okay. Okay, so I've shown how you can use salt call and state module functions to test your states, and then use linting as well to find other issues. So those tools are great for testing as you work, but they're not repeatable. Every time you make a change to a set of states, you don't want to have to sort of try and run through each of those sort of sets of tests by hand and try and do them in the same way you did them previously. Or you don't want to have to sort of document those manual tests for the next person working on your states. So what we'll do now is we'll cover using pytest and Testinfra to write tests that can do the same testing, but in a repeatable way, and with a test stored next to your states so that they can be run as needed. So pytest. Pytest is a Python testing framework designed for testing Python code, but it's extensible in such a way that we can use it to test salt states. It has auto discovery of tests, so that means it's easy for anyone or anything to run all the tests in your repo. We can make use of its fixture system and the Salt Python API to allow us to test states. We'll also use Testinfra, one of its plugins, shortly. PyTest has got lots of useful extensions for working with things like code coverage and so on, CI systems. And also, just to note that the Salt project for the main Salt repo is moving to PyTest. So I'm quite excited about there being some possibilities to use some of their work, especially things like PyTest Salt factories in future. Salt's got a Python API that gives access to the same functionality as the command line tools. We can use the Salt Python client API and replicate the functionality we've seen using Salt's call to test states, but in a repeatable and automated way. We can also add some code that will help validate the return data from Salt. Okay, so that was just running pytest against one of the state files. And as you can see, it's discovering some tests that we've written. And those tests, you can see some name, test state, show SLS, and test state apply mock, map to the testing we've done manually using salt call. Let's have a look at those. So that's what our pytest tests look like. We've got a test function for show SLS and a test function for state apply mock. So the key way this works is using pytest fixtures. So we've got some fixtures here that wrap the salt API caller, and the fixtures just allow us to call, allow us to write tests that will call state show SLS or state apply, and then the fixtures will sort of validate the return data, work out if the state module function returned okay or not, and return that value to our test. And then look at that. Yep, so that's the actual pytest fixture that we've got. So that's in the same way that we were using the salt file to pick up the local config. We're feeding that same local config into the caller object. So the testing we've done so far has either just sort of validated the states were written. The testing we've done so far has either just validated the states we've written in some way or mocked part of that process. We're actually going to want to be able to apply states and then have some automated testing that will allow us to test within the expected results. We don't normally want to do that on a local machine, as we discussed previously, the local machine probably doesn't resemble the infrastructure we're targeting, and you probably also don't want to be changing the state of your local machine. We'll come to some other ways to do testing where states are actually applied shortly, but let's have a quick look at a really simple example first. Sorry, one sec. Yeah. Okay, so we've got some so if we want to apply, so if we don't want to run tests that actually change the state of the system, what we can do is we can use pytest's ability to mark specific tests and add a config option. So we will mark tests with a tag that called allow state apply, and those tests where we're actually calling state apply and they will alter the state of the system, we won't run those unless we run pytest with allow state apply. So essentially what that means is that if we're working just on a local system, we can just run pytest. It will discover all the tests, but it will skip the tests that would alter the system. And then at a later stage, if we're using those tests elsewhere in CI or similar, we can pass that specific option and we can actually run those tests. So we'll actually run that with allow state apply. I obviously have to run it as root as well, and that will actually run the test that's that does a state apply. So as well as the show SLS apply mock, it'll run the state apply. But as I say, that's not something we'd want to do regularly on our local system. So we've covered testing that's possible in a local environment, but we've now reached a point where we actually want to apply our states and validate the results. We've also realized that using state apply against our local machine probably isn't a good idea. So containers are a way of providing us with an isolated environment where we can apply states, check the results, and then essentially throw away the environment. They also allow us to ensure that the OS, SALT, or any supporting software matches the environment our states will eventually run in. And by automating container builds, we sort of ensure that these containers are built consistently and repeatedly. Including your Docker and CI config in the same repository as your states means that you can track changes to the build alongside changes to your salt states and infrastructure. So for example, if you've got to make changes to the OS you're using in the images, and that requires you to change your tests, those changes are stored together, or perhaps you update the salt version in your container build and have that tied to changes you've made across the states. So the CI config will build a new container image when we push to a central repo, if that image is required. And then we can use those images in a couple of ways. We can either use them locally for testing to deal with sort of isolation issue, or as we'll show here, we can use those for automatically running linting and the pytest suite on every push. So within our repo, we've got a simple Docker file, which installs some prerequisites and then uses the same sort of requirements file we already had in the repo to set up a virtual env and install Salt and its dependencies. And then we've also got a GitLab CI config that will build that Docker image when we push the local repo up to GitLab. Show you what that looks like. So this is actually a job I ran earlier, just because it takes a while, obviously, to build those containers. So so essentially, you've got 3 stages. We've got the Docker build, which builds the container with salt. You then have a stage that just runs the linting. So just as we were doing sort of manually before, called YAML lint and salt lint. And then finally, we have a stage that runs our runs our pytest and Testinfra tests. So as you can see, it actually runs the state apply and validates that that works. Okay, so once you've automated building your container images with CI, it's then really easy to automate creating variations. It's rare that you have the sort of luxury of only targeting a single OS, a single version. And even if you are managing to do that at one point in time, you're going to need to be able to test against new versions before you move over to them. So by making it simple to add another OS to your testing, it means you can find some issues early on before you perhaps even have any machines running that OS. It's also easy to keep testing against some older versions. If you perhaps have got some critical infrastructure somewhere, critical machines that aren't going away, and you don't want to break them with new work or changes. What also becomes much easier is testing against multiple versions of Salt. So this is really well worth doing, as unexpected breaking changes do happen between Salt versions. Again, you can do this well in advance of rolling out a new Salt version. You can even add in testing against release candidates, which I'm sure some of the core team would appreciate if people did more. And this does genuinely help you catch issues. We had some issues with a change of behavior in command.run between particular Salt versions to do with this group the running process behaved as, which we caught with this. And we also, using a variation of this, when we were upgrading a lot of machines, or Salt on a lot of machines from Python 2 to Python 3, we sort of utilized this approach really heavily. We were able to add containers in with Py 3 versions of Salt into our testing pipeline before we were actually using that in production. And we actually found quite a few issues there. So mainly around the use of Python's Ginger templates, where the syntax, Py 3 syntax had changed. And we were able to find those and sort of fix those before we upgraded. So let's have a quick look at how that looks. I realize I'm running out of time a little bit here.
Yeah, we are running down to the last couple minutes before people need to head to their next session.
Okay.
Do you want me to start reading out any of the questions?
Yeah, sure. I'm just going to very quickly show this part of the demo. Essentially, by using sort of build matrix on GitLab CI, we're able to build against build container images for multiple combinations of OS and Salt version, and then let's see what it looks like. And then that actually means we get to build and test against all these combinations of OS and Salt version. So yeah, sorry I've run over a little bit there. If you want to read out some of the questions, that would be great.
Absolutely. So we've got one from Jim Howard. Is there a Windows-based container solution that works in this same way?
So if you, I mean, you can, I don't quite know what you mean by, sorry, so Windows-based container solution. I think you can run Docker on Windows these days, but I'm really not an expert on Windows. Certainly for the initial part of what we were discussing here, doing this local testing, that works really well under WSL and WSL2. And in fact, with various customers, that's how I've run it, because it's you know, on corporate sort of enterprisey corporate desktops, it's quite often your only option.
We've got one that actually has several upvotes. Is there a repository for code in this presentation?
I will make that available. It's not available publicly right now, but I will make that available.
Okay, where can people look out for that?
Sorry?
Where can people look out for that?
I will either post something here tomorrow, or I'll probably stick it in the community Slack when it's available.
Perfect. So if you all aren't aware, we do have the SALT community Slack that you can find pretty easily. I can post a link to it in the main event chat as well. We've got one. Do you recommend using GitLab runners for this purpose?
So I actually cut out showing doing this on GitHub Actions, which I have done as well. But yeah, I mean, GitLab runners is generally how we've done this, and you know, that's what we've used mainly.
Okay. Is there a way to use automatic testing without manual interaction, and what do you recommend?
I'm not quite sure what you mean by without manual interaction. I mean, certainly where we were testing in containers when pushing to GitLab, that is, you know, entirely automated.
Erwin, if you had more detail you wanted to add to that, you're welcome to request coming off of mute. One last one. Is there a way of testing on a Windows minion without having to provision a VM?
So testing on a Windows?
On a Windows minion without having to provision a virtual machine.
Again, I don't do a lot with Windows, so okay. I can't answer that, I'm afraid.
Okay, I think that is all the questions for now. Thank you so much for your time. This is an amazing presentation. I think it's been really helpful. We've got a lot of chatter about this, a lot of people helping each other out in the comments and giving their recommendations. This has been amazing. Thank you.
Okay, thanks very much, everyone.